Have you ever wondered how long would it take to get a cup of coffee at the DC Tim Hortons? Or where can you find a seat at the DP library? You wish there's a camera so that you can see how busy places are right now. Introducing the Crowdedness monitor. It shows you how busy places are in real time so that you don't have to worry about wasting time waiting in a queue or trying to find a seat. So how does it work? Every Wi-Fi or Bluetooth device, when probing for available networks, will unavoidably send out its MAC address, which is the unique identifier assigned to the network device. Our plan is that we can set up our Raspberry Pis in public locations like libraries and restaurants that monitors the packets the Wi-Fi devices transmit in the data link layer, which contains their MAC addresses. We then count the number of unique MAC addresses and use our algorithm to convert them into a percentage as a measure of how busy places are.
We have developed programs to capture packets and convert them into metrics. We also created backend servers to collect data from embedded systems. In addition, we used machine learning algorithms to predict future trends based on historical data. Furthermore, we designed and implemented front-end websites to display the data and obtain authorizations to deploy to devices in DC and DP libraries. Some people might think our project can cause privacy issues, but in fact, we don't collect any MAC addresses or any other information from your devices, as we are only concerned with the number of the devices. Also, it's completely open source. You could always find it on GitLab if you want to.
This diagram illustrates how each module interacts with each other. The whole system can be divided into three parts, namely the back-end, front-end, and embedded systems. The embedded system part consists of Raspberry Pi instances installed in public locations, each of which will probe packets and count the number of unique MAC addresses every 5 minutes, and then they will send the collected data to the backend. The backend stores the data into the database and responds to the front-end's request. We are choosing to use Raspberry Pi 0W as the data collectors since they are relatively affordable and energy efficient. The backend uses Flask and Scale Alchemy for web API access and database management. As for the machine learning part, sklearn and LightGBM are used. And lastly, the front end is a web app written in React.
We are solving clustering and time series prediction problem. We use k-means for clustering, which can show a basic tendency of crowdedness for weekdays. For prediction of the future, we use another machine learning model called LightGBM. Since it is a powerful tree-based model, it can automatically rank the importance of linear features. We take in past data and extract features such as weekdays, hours, and minutes, and these features are turned into a sparse matrix by one hot encoder to be used as a linear features to feed the model. We chose to use this model as the amount of data is not sufficient for a neural network like RNN or LSTM. The end product has a decent accuracy with root mean square error being around 40 for DC library and 15 for DP library because we have a relatively large data set for training the model DP library.
So there are a few improvements we can make in the future. The first one is adding more probing stations to achieve better coverage and higher accuracy. A second thing we're trying is the integration of a noise detector into devices, as noise is a potentially good measurement of crowdedness. Furthermore, we can employ a real-time user feedback system and apply deep learning to enhance our predictions. And aside from the website, we can develop mobile apps that can be downloaded to everyone's devices.